This is PreCalculus 12, Chapter 7.6. We're going to be looking at double angle identities. So cos 2 theta equals cos squared theta minus sine squared theta. It's easy to derive this because we have cos theta times cos theta minus sine theta sine theta using the sum formula. And for sine 2 theta is 2 sine theta cos theta. And here we have sine theta cos theta plus cos theta sine theta. So we rearrange this and we can get 2 sine theta cos theta. And for tangent, we have tan theta plus tan theta over 1 minus tan theta times tan theta. And we add these two, we get 2 tan theta, and we multiply these two, we get tan squared theta. Okay, from cos 2 theta, we can do some substitution. We can substitute sine squared theta plus cos squared theta equals 1. And we come up with more formulas. So we have cos 2 theta equals 2 cos squared theta minus 1. Cos 2 theta is also equal to 1 minus 2 sine squared theta. And we can also get cos 2 theta plus 1. That's just moving the 1 over to the other side equals 2 cos squared theta. This time we'd swap the sine and the cos 2 theta, so we get 2 sine squared theta equals 1 minus cos 2 theta. It's always important to be able to prove these things so that we know that they're true and not just take it for granted. Okay, so here are some half angle identities. These are helpful. It's not required in the curriculum, but if you're doing calculus, you should have these on your reference sheets, something you can remember. So if we solve for cos theta, we get cos theta equals plus or minus square root 1 plus cos 2 theta over 2. We do the same thing with sine. We do some algebra. We get sine theta equals plus or minus square root 1 minus cos 2 theta over 2. So let's try some problems. Simplify. It means find the identities. So we have sine cos. We have a 2 out front. We look at the identities. And it matches this one. So this is sine 2 theta. And theta is pi over 4. And we simplify this. This is sine pi over 2. And we can simplify that to 1. Remember, the sum sine identities have sine and cos multiplied together. In the cos sum identities, we have cos times cos and sine times sine. So this is a cos identity, cos 2, 30 degrees. This is cos 60 degrees, and that's a special angle, which means we have a special ratio, and that's 1/2. And we have the 2 tan over tan squared, so that's just the tan 2 times 22.5 degrees. That's tan 45 degrees. That's a special angle, so we need the special ratio, and that's 1. Find sine 2 theta and cos 2 theta given that sine theta is equal to 3 over 5. Again, for this type of problem, we're not actually required to find alpha. It's not a special angle. So we can find cos theta. It's unknown. This is y over r. Now we're finding x over r. And finding x, we have to use the Pythagorean. So this is negative r squared minus x squared. And we get negative 4 over 5. We see this triangle a lot, so you should memorize this Pythagorean triplet. Other Pythagorean triplets that are easy to remember is you can just take the multiple of this. 6, 8, 10. So, and we also have 9, 12, 15. So these are just multiples. Another Pythagorean triplet that's easy to remember is 5, 12, 13. Sine 2 alpha is 2 sine alpha cos alpha. We figured both of these out. We just need to substitute them in. So 2, 3 over 5, and negative 4 over 5. Now, a common mistake that students make is they figure out these ratios and then they take sine 3 over 5 again, and they do cos negative 4 over 5. Please don't do that. These are already the ratios. Don't plug them in as angles. Multiply the numerators, multiply the denominators, we get negative 24 over 25. Cos 2 alpha. So we have cos squared alpha minus sine squared alpha. Substitute the values, negative 4 over 5 squared minus 3 over 5 squared. That's 16 minus 9 over 25, so that's 7 over 25. We have a lot of work, so box your answers. Okay, again, this is not required, but I'm going to show you an example of this. Find the exact trig ratios for 67.5 degrees. This is half of a special angle. So if we multiply this by 2, we get 135. 135 is our special angle. So we use the half angle formula. Sine 67.5 degrees equals positive 1 minus cos 135 degrees divided by 2. And we can substitute the exact values. So we have to find a common denominator, multiply this by root 2 over root 2. This goes to the bottom, and we have 1. So why don't we use negative? Well, we're not using the negative ratio because we know what quadrant we're in. 67.5 degrees is in quadrant 1, so we wouldn't have a negative ratio for sine in quadrant 1. So don't use these formulas blindly. Reason out what quadrant you're in and choose the appropriate positive or negative sign. Cosine 67.5 degrees. So we have 1 plus cos 135 degrees over 2. And substitute and reduce to this. We can do the reciprocal functions by just reciprocating this rational. And tan 67.5 degrees. You can use the tangent formula, but since we've already calculated sine and cosine, it's probably best to stick with that. Things cancel out in the denominator, so we just have the numerators. And this is the numerator of the denominator, so it goes into the denominator. And again, for the reciprocal function, just reciprocate this rational. Next problem. Solve over the domain negative 2 pi to 2 pi. We could use the identity for sine squared and get cosine squared, but we still have this as a problem. So it's best to use this identity first. And the cosine double angle identity has lots of options in it. So we can go to complete cosine, we can go to complete sine. And in this case, it makes sense to go completely to sine because we already have sine. Okay, so doing proofs, you want to be able to think ahead like in chess or checkers. Think a few moves ahead to see that if that gets you anywhere. So 3 sine squared x plus 1 minus 2 sine squared x minus 2 equals 0. Okay, now we can expand this term. 3 sine squared x minus 2 sine squared x is sine squared x. 1 minus 2 is negative 1. So sine squared x equals 1. Sine x equals plus or minus 1. This is a special ratio. The period is 2 pi over b, which is 1. So that's 2 pi. Remember, this is min or max, and we have the period being 2 pi. And for min or max, we don't need to do the quadrants. We just need to look at the chart or remember the angles. And this is pi over 2 and 3 pi over 2. And these are our two positive answers. We have 2 revolutions, so that means we need to multiply our answers by 2. And to get the other ones, we have to subtract 2 pi. So pi over 2 minus 2 pi, that's pi over 2 minus 4 pi over 2 because we need a common denominator. And we get negative 3 pi over 2. We take 3 pi over 2 minus 2 pi, 3 pi over 2, again common denominator, minus 4 pi over 2, and we get negative pi over 2. We have 4 solutions. It's best to write them in increasing order and then box it. Negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and then we notice our spacing. And we say it's just pi over 2 plus n pi. And we do this because we notice that we have all the odd numbers times pi over 2. Let's look at a proof. Use the double angle identities to prove. Okay, this is a long proof. It takes work, but be persistent. Right hand side, 1 plus cos theta over tan theta plus sine theta. We want to change everything into sine and cos, so use the tangent here. 1 plus cos theta over sine theta over cos theta plus sine theta. We want a common denominator in the denominator. 1 plus cos theta sine theta over cos theta plus sine theta cos theta over cos theta. And we want to simplify this. I'm just going to write it over here. 1 plus cos theta over sine theta plus sine theta cos theta over cos theta. Make sure you keep your fractions lined up. This is a fraction. We want this line to be shorter than this line, which means divide. Now we want to multiply by the reciprocal of the denominator. This fraction is the denominator, so we need to reciprocate it and multiply. So the cos is going to come up in the numerator. So we have cos theta, 1 plus cos theta, sine theta, plus sine theta cos theta. We want to factor out the sign in the denominator. Cos theta, 1 plus cos theta over sine theta, 1 plus cos theta. Okay, so when we factor out the sign, we're dividing by 1. We get 1, we get cosine. And we want to cancel out the common factor, which is 1 plus cos theta, so we now have cos theta over sine theta. Okay, looking back, how do we get these two to look alike? So this is where you might want to do some reverse engineering and work with both sides. So left-hand side equals 2 cos squared theta. This is temporary work. It's not part of our solution. We notice that this is a double angle identity, so we get 2 cos theta, cos theta. I just want to break that out by itself. Makes it clear. 2 sine theta, cos theta. It makes it more obvious of what's going on. So we want cos theta over sine theta, which means we're going to cancel out a 2, and we're going to cancel out cos theta. Now we see what we need to do. We reverse engineer it. We're multiplying by 1, so we have cos theta over sine theta, and we're multiplying by 2 cos theta over 2 cos theta. And we distribute. We get 2 cos squared theta. We get 2 sine theta, cos theta. So we're just rearranging it so that we can see the double angle identity. 2 cos squared theta over sine 2 theta equals left-hand side and QED. Okay, so here's an example of where it's a good idea to work with both sides, but you still have to write out the proof the proper way by working on one side. And that completes this lesson and chapter.